Stop worrying about homework and start learning with confidence. This is Ask Learn. Complete help for every subject. Like, share, subscribe for daily learning videos.
Alright, let's start with writing down everything that we know. We know the velocity, v, is 4.5 times 10 to the 6th. And that's in meters per second. We are given the force produced by the magnetic field, so I'll abbreviate that F sub B. That is equal to 8.0 times 10 to the minus 14th. Now our force, as usual, is in newtons. So, we're given that this is a traveling proton going at this speed. So another thing we'll want to note is the charge of a proton. Is 1.6 times 10 to the minus 19th power. And that is in coulombs, unit of charge. That is the charge of a proton. So electrons and protons share the same charge. Point of note, electrons are just oppositely directed, oppositely charged. Now the equation we're going to want to use to find the magnetic field is given by B is equal to F divided by the charge multiplied by V sine of the angle between the velocity and the force. Theta. Now we are given in this problem that the velocity is traveling east and the force is directed south. So let's write that out. So we have our velocity and our force. These are 90 degrees to each other. So we have sine of 90 degrees, or sine of pi over 2, which is equal to 1. So we don't need to keep that in this equation. Now, this is a straight up plug and chug. We have everything we need to calculate it, but we need to find out the direction. So you can find this from using the right hand rule. If you hold your right hand palm upwards out in front of you, point your thumb out to the side, point your pointer finger directly forward, and then your middle finger will point up in the direction your palm is facing. They should all be at right angles to each other, all perpendicular. So your pointer finger is the direction of the B field, your thumb is in the direction of the velocity, and your middle finger will be the force. So if we orientate our right hand in the direction we're given, so we have velocity to the east or to the right, and then we have the force is south. So you'll have to bend your right hand around so that your middle finger or your palm is facing downwards and your thumb is pointing to the right. That should leave your pointer finger facing directly at your face or your chest, depending on how you're able to angle your hand for that. But for this diagram, this is a three-dimensional problem, but we only have 2 dimensions here, so this is going to be coming out of the page, which is represented by a circle with a dot. Whereas into the page is represented by an X inside of a circle. This is out of the page, this is in. Okay, so now we have direction squared away. We can calculate this out. Plugging in all of this gives you that B is what we're solving for. The magnetic field is equal to 0.11. So we have a number. Let's make sure it's what we want by double checking with our units. So F is in units of newtons. Q is in units of coulombs. C, and now V is in units of meters per second. So it's coulombs times meter per second. And if you wanted to help you see the next step here a little bit easier, you can put the coulomb in the numerator here. Just coulomb times meter divided by second. So what we want to do is move this second up to the numerator. We can do that. You can see it a little bit easier if you just write it as seconds over 1. To move it up, you just flip it. So this is in this denominator here. So we'd flip it so it would be seconds over 1 multiplied by that. So what we're left with is Newton times second over Coulomb times meter, or meter times Coulomb, which is the definition of the Tesla, which is our units for magnetic field, abbreviated as T. So now we have our final answer. B is equal to 0.11 Tesla. Now to find what would happen with an electron, as I said earlier, electron and protons have the same charge. That wouldn't affect any of the numbers. For the proton, it's directed out of the page, as we discovered with the right-hand rule. With a negative charge, you do the opposite of what you find with the right-hand rule to make things even more confusing. So we found that this points out of the page. With an electron, it's just, imagine your middle finger pointing in the opposite direction it's actually pointing, so it would be pointing into the page, which is the opposite of what we found for the proton. So for part B, we have an electron that would be into the page. Same number. And there you have it.